Okay, so with the tangent function, I have it graphed right here. We want to talk about, first one, what does the period of the tangent function appear to be? Let's see what you guys think. You guys have been working on it for a little bit. What do you think the period is? 4. How do you get 4 out of that, Trayson?
Every 4.
Well, what do you mean every 4?
Every line.
Every 4. So every one of these tick marks, is that what you're talking about?
Every pi.
Okay, so every tick marks, you say that happens. Well, how much is 4 tick marks? Pi, right? Every pi units, there's one of these happening. And that's exactly right. If you take right here, if we draw a line straight up right there, and straight up right here, okay, between those 2 vertical lines is 1 cycle. Period is how long does it take for 1 cycle to place? Well, it takes place between this line and that line. Well, what is the tick mark right here, you guys? Yeah, negative pi halves, because each one of these tick marks represents pi fourths. What is this tick mark right here? Pi halves, positive pi halves. And so if you go between negative pi halves and positive pi halves, that's a total distance of pi units. Do you guys understand that? What's the period of the tangent function? Pi. Because between negative pi halves and positive pi halves, 1 cycle takes place. And then it repeats the pattern. Between positive pi halves and this vertical line. Where does this vertical line cross the x-axis? 3 pi halves, that's right. Okay, so it crosses at 3 pi halves. And so, once again, another cycle takes place between pi halves and 3 pi halves, which is a total distance of pi. So, when we talk about this, the tangent function, its period is pi. What was the period of the sine and cosine function? 2 pi. It took a whole 2 pi to do 1 cycle of the sine and cosine function. It takes pi units to complete 1 cycle of the tangent function. Okay, any questions on period? Okay, now, question number 2. What is the domain of the tangent function in the given window? Now, let me explain this, because some of you guys apparently don't understand asymptotes very well. But all these vertical, you guys got to quit talking. You got to listen if you're going to get this. All these vertical lines are the imaginary barriers, the asymptotes I was talking about, where the graphs are going to get closer and closer to them, but they're never going to touch them. So like, if I take this other color right here, as I trace this right here, this middle one, and I go up right here, it is getting closer and closer to that red line, but it will actually never cross it. It's going to get so infinitely close. The higher you go, the more infinitely close it gets it. It's going to be so close that it might as well be a vertical line, right? But technically, it's not. It has a slight slope to it, okay? So they're getting closer and closer, but they'll actually never cross through there, because if you put pi halves in there, look at the unit circle over here. Look at pi halves. The tangent is defined to be y over x. 1 divided by 0. What's the problem with 1 divided by 0? 0. No, 1 divided by 0 is not 0. It's undefined, right? And where else is it undefined?
Down there.
3 pi halves. And if I go around again, what would the next one be? Watch my hand again. Everybody's eyes got to be right here, okay? That is pi halves. And it's undefined there because 1 divided by 0 is undefined. If you go down to 3 pi halves, negative 1 divided by 0 is undefined. If I go clear up to here, what's the next number? 5 pi halves. And it's going to be 1 over 0 because it's going to use those same coordinates every time. And then what's going to be down here again? 7 pi halves. Then what? 9 pi halves. Then what? 11 pi halves. They're all odd numbers, aren't they? Odd pi halves. So when I state the domain, I'm going to say all real numbers except what? All reals. X is not equal to odd pi halves. I'll make that bigger for a second so you guys can see what I wrote. all reals, x is not equal to odd pi divided by 2, odd pi halves. You can write it in English too if you need to. Okay? So that's what it is right there. Okay, so the domain doesn't exist where those asymptotes are. Okay, question number 3. What is the range? What is range again? The y values. How high does this function go? To infinity. How low does it go?
Infinitely low.
So what is the range? All real numbers. All real numbers. All reals. It can go up forever and down forever. Okay. What did you guys come up with the x-intercepts? You discussed that yourselves. What did you come up with? All the pi's? Where else? 0. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. So what's the way we can say that? It's not just all pi's, right? So it's multiples of pi. So, okay, multiples of pi. Yep, you can put pi k. Multiples of pi, or you can put pi times k, where k is an integer. That would include all the integers. Pi times k would include 0, -1, -2, -3, and +1, +2, +3, and so forth. Okay? All right, next. What is the y-intercept? Where does it cross the y-axis? 0. Okay? So 0. And the last question. Where are the vertical asymptotes located? We already said those, right? They're located where the domain is undefined. Where are they located? So at x equals pi halves, x equals 3 pi halves, but there's an infinite number of them. So how do we list them? We can say odd pi halves, or we can say x equals pi halves k, where k is an odd integer. Because you put in 1 times pi over 2, 3 times pi over 2, 5 times pi over 2, 7 times pi over 2. Does that make sense? So where k is an odd integer. Okay, so if you just keep multiplying by k each time, you get that. Does that make more sense to you now? Okay, do you understand what you're doing? Okay, because we are going to now do the same thing with the cotangent. How do you graph the cotangent function in your calculator? Say that again. Negative cosine?
Inverse.
No, that won't work. Inverse? No, that won't work. What? Inverse won't work. Say 1 over tangent. Do you guys remember that? We learned that. Since tangent and cotangent are reciprocal functions, you're going to graph them in as 1 over tangent. 1 divided by the tangent of x. That's a reciprocal, not an inverse. Do you guys understand that? Okay, so you graph it on the same thing. What's something obviously different right now that you can see? Say that again, McKinnon. It's going down left to right, right? I should have said this about the tangent function. Everybody go back to your tangent function notes and say, it is increasing function. It increases as you move left to right. Each cycle increases, right? And what does each cycle, McKinley said it right here, what does each cycle do right here? Decreases, right? Okay, so each cycle right here is decreasing as you move left to right. Okay, so I'm going to pause this. I want you guys in your groups to answer the 6 questions, okay? So let's discuss them. Starting with number 1, I'm going to call on some of your groups and tell us what you got. Let's see this group right here. What did you guys get for the period? Pi. So it looks like it occurs every pi units, just like the other one, right? Okay, good. Yeah, if you look at it, every cycle, the first cycle takes place between 0 and pi, right? Second one between pi and 2 pi. So every pi units is the period. Yeah. Question number 2. What is the domain of the cotangent function in the given window? Well, to determine domain, we really have to go actually answer question 6 first. Right? Okay, yes.
On the number 1, it says like the period. Wouldn't it not actually be pi because it never actually touches that?
No, the period is what much space it takes between to do it. It doesn't actually touch it,
Yeah,
so
technically it's not.
it's
Technically
slightly
so
under, yeah. But one cycle takes place between 0 and pi, so they call it pi. Okay, yeah, I understand what you're saying. Okay, so to answer question 2, we need to really answer question. Okay, so let's go down and answer question 6. Where are the vertical asymptotes located?
No, I know.
Multiples of pi and 0. Because right at 0, you can see the y-axis is the vertical asymptote. That graph is never going to touch it. If you go over to pi, same thing. You go over to 2 pi, same thing. You go to negative pi, same thing. Negative 2 pi, same thing. And it's going to continue that pattern. Tracing.
Is it not x equals pi over 2k?
Not pi over 2k, no. Pi times k.
Wait, hold on.
It's not pi halves k.
Oh, 2 pi halves times k.
It's not pi halves times. That was what tangent was, because tangent ones happened to pi halves and 3 pi halves and 5 pi halves. It was all multiples of pi halves. For this one right here, every pi units, see, right here, right here, right here, right here, these are all asymptotes. It's crossing through. That's 0, that's pi, that's 2 pi. Do you understand what I'm saying?
Yeah.
Trayson? Okay. Trevor?
So you said that it was like multiples of 0 and pi? But
Well, multiples of pi.
okay.
Because if you go 0 times pi, you get 0.
Yeah,
Okay. So multiples of pi.
I just want to say.
But I just wanted to make sure you guys understood 0. Okay? All right. Okay. So the vertical asymptotes, number 6, this question right here is multiples of pi are where the vertical asymptotes occur. So now we can answer question 2. What is the domain? All reals except for multiples of pi. That's right. Good. Everything but multiples of pi. Okay, I want everybody to turn. I want all A's. Who are the A's? Okay, you should have said, I'm going to record this because I had it off when I said it. You should have said something like, the domain is all real numbers except multiples of pi. Okay, question 3. What is the range? How far up and down does this go? All real numbers. That was an easy one. This is an easy one. Where are the x-intercepts located? All odd pi halves. Because look, it crosses the x-axis at pi halves right here, at 3 pi halves right here, at negative pi halves here, at negative 3 pi halves here, same as where the asymptotes were on the tangent function, right? So it's odd pi halves. No, because yeah, this is pi halves, and then that's 4 pi halves right there, which is,
Oh, that's what I said.
that's 2 pi halves, which is 1 pi, 3 pi halves, 4 pi halves, which is 2, 5 pi halves, so it's at the odd pi halves. Okay, question number 5. What is the y-intercept? Here's another question. There is none. Well, it is applicable, because the question is there are not any. You need to know that. Because there's an asymptote there, so it's never going to cross the y-axis. Okay? And so we've answered all those questions. Okay. We're going to go look at the cosecant function. This one's a little different. Cosecant and secants are different. You guys notice the sine and cosine were similar. Tangent and cotangent are similar. You'll find out the secant and the cosecant are similar. How do you put the cosecant and secant in your calculator? No, this is a cosecant. How do you put the cosecant into your calculator? Let's go there. What? 1 over sine of x. That's right. 1 divided by sine of x. Any question on how you put the cosecant in your calculator? 1 over the sine of x. It's the reciprocal. It's the reciprocal of the sine function. I'm going to do this one with you guys, and the next one you're going to do on your own. Okay? So here we go. Question number 1. Okay? Does this have, by the way, does this have asymptotes?
Yes, it has to.
Okay. It does. Why?
Because
Well, think about the function we put in, 1 over sine of x. What if the sign is 0, right? Where is the sign 0? Look at the unit circle right over here. Where is the sign 0? Where is the y value 0? At 0, at pi, at 2 pi. The y value is 0, so it's 1 over 0. It's undefined right there. Do we see that? Okay, so there is an asymptote right here, right here, right here, right here, right here. Those are asymptotes. Okay? So, and by the way, do you guys notice the gap in between where the graph does not exist? What's the highest point of this graph? Right there. Does a graph exist between -1 and +1?
No.
Okay. So actually,
So our range isn't.
okay, I want you guys to discuss all 6 questions really quickly. I'm going to give you a couple minutes. Go. Okay, let's just discuss it. What's the period? Okay, Cameron says 2 pi. Why do you say 2 pi, Cameron? Okay, so does everybody agree with that? She says there's an up one, then a down one, then an up one, down. So it takes an up and a down one to make one whole period. Would you guys agree with that? She's saying that it's going to take one of these and one of these to create a period. Do you think that's true or not?
Yeah.
Yeah, they're 2 separate things, aren't they? So it's going to take both of them to create that. So the answer, Carly, is 2 pi for the period. Do you understand that?
Yeah.
Okay. You got this one down? Okay. All right. Let's talk about the next question. What is the domain of the cosecant function in the given window? What is the domain of this function? By raise a hand. I want to see. Someone raise your hand and I'm going to call on you. Or I'll call on someone anyway. I'm going to call on Alyssa. What do you think the domain of this is? You didn't figure out the domain? Sam probably did, so I'm going to ask Sam. Yeah, what's the domain of this function? What? Where do the asymptotes occur? I'm going to go on to someone else. Noah, where do the asymptotes occur? At the pi's, aren't they? Good. So what is the domain?
All real numbers except for multiples of pi.
All real numbers except for multiples of pi. Because right here, you guys, let me erase these again. Right here, there's an asymptote. Right here, there's an asymptote, right? Right here, there's an asymptote. Right here, there's an asymptote. Right here, there's an asymptote. Okay, so the graph is going to get closer and closer to it, never touch it, but they always occur at pi. Remember, this is pi force, pi halves, 3 pi force, pi. Each one of those tick marks represent pi force. So at every pi units, you have an asymptote. So the domain is all real numbers except for multiples of pi. Okay, question number 3. What is the range? Braden? Huh? There wasn't a range? There is a range. There is a range. Haley, what's the range?
All real. No.
Okay, good. Haley said it right there. She says -1 to -infinity, +1 to +infinity, because this graph only exists, you guys, only exists, there's a big gap between -1 and 1, isn't it? So the graph only exists where x is less than -1, or y is less than -1, less than or equal to -1, and y is greater than or equal to +1. You can write it like that. So that goes. Yeah, it actually touches the ones. In fact, in just a second here, Trevor, I'm going to show you guys something really cool, how the cosecant and the sine function relate. It's kind of cool, and you'll see how they touch. Okay? They touch. Because at if you go to pi halves, the cosecant of pi halves would be 1 over y, 1 over 1. which is 1. And the sine is 1 also. And so they both have the same value right there. So I'll show you that in just a second. Okay, next question. Where are the x-intercepts located?
None.
Carissa, where are the x-intercepts located? Never intersects the x-axis, does it? Okay, Trayson. I know, but ask the question. Either raise your hand, wait to be called on, or let me call on someone else and let them say it, okay? All right. Number 5, what is the y-intercept? Alex. What is a y-intercept? Huh? There are none. It doesn't cross y-axis because there's an asymptote right there, right? Okay. Number 6, where are the vertical asymptotes? We already answered this question. Where are the vertical asymptotes? Coulter, where's the vertical asymptotes? At multiples of pi. Okay. All right. Next one. Last one. Here we go. Okay, this is a secant function. How do you put that in your calculator? 1 divided by the cosine. So 1 divided by the cosine of x. Oh, I forgot to show you how the sine and the cosecant were related, didn't I? Remind me on this one. I'll show you how the cosine and the cosecant or the secant are related. Okay, you guys answer the questions. I'll give you a few minutes. Okay, starting with Taylor. Taylor, what does the period of the secant function appear to be? 2 pi. Why? Okay, every 2 pi it repeats itself. So what? Show me up there. Go up there and show me what. Show me one period. Show me what parts are one period. Okay, so one of the up ones, one of the down ones, right? So for example, this would be one period, right? From there to there, she said. That's a distance of 2 pi, right? Okay, next question. What is the domain of the secant function in the given window? Hunter. Well, where are the asymptotes? There's an asymptote. What's this tick mark? Quarter pi. What's that one? What? Half pi, right? Pi, odd pi halves. Guys, there's an asymptote at odd pi halves. Okay, so the domain. Hunter, now that you know it, state the domain. Exactly. Everybody say that. All real numbers except for odd multiples of pi halves. Okay. Exactly. Okay. Question number 3. Brooke, what is the range? Same as the last one. State it. How do you state it? Okay, less than or equal to -1 and yep. So, did everybody get the range? Y is less than or equal to -1, y is greater than or equal to +1. Okay, number 4. Where are the x-intercepts located? Andrea, where are the x-intercepts located? 0, 1? No, where's the x-intercepts? There aren't any x-intercepts. Cheyenne, what's the y-intercept? Cheyenne, what's y? 0, 1. Good job. Okay, it crosses at 0, 1. Number 6. We already asked this question, but I'm going to ask again. Carly, Dylan, where are the vertical asymptotes located? Did you say that again? Odd pi halves, right? Okay, good. Okay, you guys, let's review. What is the period of each function? Tell your face partner. Go. Okay, I am going to call on Caitlin. What is the period of the sine function? Okay, Jalee, the cosine function. Cosine function, what's the period? I'm going to come back to you. What's the period of the tangent function? Phi. Okay. Trayson, what's the period of the cotangent function?
Oh, I know this one. Pi.
There you go. Okay. Sam, what is the period of the cosecant function? No. Yeah, 2 pi. Okay. Jalee, what's the period of the sine function? The cosine function? No, I'm going to come back to you. Okay. JD, what's the for the secant function, what's the period?
Secant is opposite sine, right?
What's the period of this? Yeah,
Opposite sine. 2 pi.
2 pi. Trayson,
So cosine and sine are both 2 pi, then their opposites are both 2 pi, and tan comes in at pi.
that's right. Did you guys all hear that? Jalee, you got that? Sine, cosine, secant, and cosecant are all 2 pi. Tangent, cotangent, period of 1 pi. Okay? All right. Hey, I forgot to show you guys how this one relates right here. So let me show you right here. If I go into my calculator right here and I put in a cosine function, and you graph it, look. Cool, huh?
It touches at this.
I know I did that. That's funny.
Okay? The sine function and the cosecant function do the same thing. So at 0, we both have the secant and the secant and the cosine both have a value of 1, right? At 0. At pi, they both have a value of -1. At 2 pi, they both have a value of 1, and so forth. I think that's going to be one of the questions on your homework assignment today. Okay? That is cool.
Both of them.
Okay, last question, you guys, before I give you the thing. We're going to, you know what? We're going to skip this part today. We'll probably play it next time. Here is your assignment.